Hello teacher, today I will talk about computer network. In chapter 1 is introduction. Chapter 1 outline overview of the internet, protocol layering, internet history, and standard and administration. Objective: we introduce local area network, LANs, and wide area network, WANs, and show that an internet or the internet is a combination of this network. We introduced the concept of protocol layering to show how the task to be done by the internet is divided into smaller tasks. We also discussed TCP/IP protocol suite and show the duty of each layer. We give a brief history of the internet. We introduce the administration of the internet and define the standard and their lifetime. Overview of the Internet. We start our journey by first defining a network. We then show how we can connect network to create small internet network. Finally, we show the structure of the Internet and open the gate to study the Internet in the next 10 chapter. Network. A network is the interconnection of a set of devices capable of communication. In this definition, a device can be a host or an end system, such as a large computer, desktop, laptop, workstation, cellular phone, or security system. A device in this definition can also be a connecting device such as a router, a switch, a modem that changes the font of data, and so on. Local area network, wide area network, point-to-point WANs, switch WAN, and internet network, and isolate LAN in the past and today. In the past, have many items or many connect to use in LAN, but today we have only switch to connect with host. And this is description on the symbol. Point-to-point WAN. This is network topology type. Have a point-to-point, have a bus, have a link. Network is connect like this, like a star, like a T, like a mass, like a hybrid. And network connect like this, and this is description of this symbol. Also with one. In this picture, in square like connect like WAN, like a connect in global level, and author or out of is like a connect in country. An internet network made of two LANs and one WAN. This picture is in the network or internet. In this variable, in this picture, use point-to-point type and another level in LANs. Just like this, connect to each host in a heterogeneous network made of WANs and LANs. We have a host and many hosts connect in LANs level and in global level or in WANs level. We connect with switch and then we connect by point-to-point type, and this picture will be like this. Switching. An internet is a switch network in which a switch connects a list to link together. A switch needs to forward data from a link to another link when required. Circuit switch network. packet switch network. In a circuit switch network, in this picture, internet line is high capacity line and back line is low capacity line. In a circuit switch network, a dedicated connection called a circuit always available between two end system switch, making it active or interactive forwarding stacks. First case is fully used. In the second case is 1/4. In this picture, also in the lead line is high capacity line and back line is low capacity line. And in this picture is auto function for stalling and forwarding the internet. The most notable internet is called the internet, and this composed of thousands of interconnected networks. Picture 1.8 shows a conceptual, not geographical view of the internet. In this picture 1.8, the internet today. For this picture, backbone is complex switching system, and in top is peering is the process by which two internet networks connect and exchange traffic, and then it connects. And the below is Internet Service Provider (ISPs), International ISPs, National or Regional ISPs, and then is Connect to. All of this is connect to peering point. Accessing the Internet. The Internet today is an internet network that allows any user to become part of it. The user, however, needs to be physically connected to an ISP. The physical connection is normally done through a point-to-point WAN. In this section, we briefly describe how this can happen, but we postpone the technical detail of the connection until chapter 6 and 7. Using telephone network is have dial-up service, DSL, digital subscriber line, and we have using cable network, using wireless network and direct connection, hardware and software. We have given the overview of the internet structure. For communication to happen, we need both hardware and software. This is similar to a complex computation in which we need both a computer and a program. In the next section, we show how this combination of hardware and software are coordinated, which is altered using protocol layering. Protocol layering. What we hear all the time when we talk about the internet is protocol. A protocol defines the rules that both the sender and receiver and all intermediate devices need to follow to be able to communicate effectively. When communication is simple, we may need only one simple protocol. When the communication is complex, we need a protocol at each layer or protocol layering. Scenario. Let us develop two simple scenarios to better understand the need for protocol layering. We have first scenario, second scenario, and principle of protocol layering and logical connection. For this picture is a single layer protocol. In layer 1 is listen and talk between Maria and Anne. Is a set of rules such as friend, greet, confine, different, dialogue, exchange, and the question is, what about the communication between a professor and the student in a lecture? It's just like In this picture, listen and talk. In layer 1. In figure 1.10, a 3-layer protocol. This is principle of protocol layering. We have layer 3. It's the same. Listen and talk. In layer 2 is encrypt and decrypt. In layer 1 is send mail and receive mail. All of these have a identical object, and in this layer protocol, postal carrier facility protocol layering enables us to divide a complex text into several smaller and simple texts. Modularity, independent layer, a layer module, black box with input and output. Advantage, separate the service from the implementation intermediate system. Is this any disadvantage to protocol layering? Is a lower performance. To another picture is logical connection between peer layer. A peer is someone at your own level. This is layer-to-layer communication. In layer T is talk and listen. In level 2 is encrypt and decrypt. In level 1 is send mail and receive mail. All of this is logical connection. TCP/IP protocol suite. TCP/IP is a protocol suite used in the internet today. It is a hierarchical protocol made up of interactive modules, each of which provide a specific functionality. The term hierarchical means that each server-level protocol is supported by the service provided by one or more lower-level protocols. The original TCP/IP protocol suite was defined as 4 software layers built upon the hardware. Today, however, TCP/IP is thought of as a 5-layer model, and this half-layer architecture layer in the suite. Description of this layer have a application layer, transport layer, network layer, data link layer, and physical layer. Encapsulation and decapsulation. Encapsulation at the source host, decapsulation and encapsulation at router, decapsulation at the destination host, addressing, multiplexing, and demultiplexing. In the future, is layer in the TCP/IP protocol suite. In the left side is original layers, and in the right side is layer used in this book. In layer 1 is application, layer 4 is transport, layer 3 is network and internet, layer 2 is network interface and data link. In layer 1 is hardware device and physical. And this picture is communication, start, and internet. We have device like host, communication from A to B or from left side to right side, and this is detail how it used in each layer, and is how it works. Source A to switch to router to switch and to destination B. All of this is layer architecture, and this picture is logical connection between layers in TCP/IP. It also from left side to right side, from source host to destination host, and this is detail also. It's a logical connection. And what is how it works? It's like layer, application to application, transport to transport, network to network. Data link connect to router, and then router send to destination host like this. The duty of the application transport and network layer is end-to-end domain internet. The duty of the data link and physical layer is hop-to-hop. A hop is a host or router. Domain is link. This is the data unit packet. This picture is identical object in the TCP/IP protocol suite. And this is detail. Note we have not shown switch because they don't change object. And this how it works. In this layer, identical object is message. And this is segment or user datagram. And in network layer is datagram. And data link, identical object is frame. And physical identical object is bit. This picture is a router may fragment the packet at the network layer and send more packets than receive. Encapsulation and decapsulation. For this detail, in the left side is source host and right side is destination host. In this symbol and how it works. For this is detail to describe the symbol. In down arrow is a encapsulate this and this, and upward arrow is a decapsulate. In this picture will be addressing in the TCP/IP protocol suite. Half detail is packet names, layer, and address. Like packet name is message, layer is application layer, and address is name. And this is segment user datagram. Layer is transport layer, and address is port number. Packet name is datagram, layer is network layer, and address is logical address. Packet name frame, layer is data link layer, address is link layer address. And last is packet name is bit, and layer is physical layer. And this picture will be multiplexing and demultiplexing. In picture A is multiplexing at source. You can see it's a down arrow, top to down. And for picture B is a demultiplexing at destination. You can see it's a upward arrow. The OSI model, established in 1947, ISO is a multinational body dedicated to worldwide agreement on international standards. An ISO standard that covers all aspects of network communication is the Open System Interconnection (OSI) model. It was first introduced in the late 1940s. However, OSI versus TCP/IP and lack of OSI model success. This picture is the OSI model. have several layers. For layer 7 is application, for layer 6 is presentation, and then have a section, transport, network, data link, and physical for layer 1. In this picture is TPC, TCP/IP, and OSI model. This picture is compare. For brown color is several application protocol. For blue color is several transport protocol. For orange color is internet protocol and some helping protocol. For data link is for green and yellow color is underlying LAN and WAN technology. For internet history, now that we have given an overview of the internet and its protocol, let us give a brief history of the internet. This brief history makes it clear how the internet has evolved from a private network to a global one in less than 40 years. Early history. There were some communication networks such as telegraph and telephone network before 1960. These networks were suitable for constant late communication at a time, which means that after a connection was made between two users, the encoded message telegraphy or voice telephony could be exchanged. We have a birth of packet switch network, opponent advanced research project agency network, birth of the internet. In 1972, Winchester and Bob Kahn, both of whom were part of the opponent group, collaborate on what they call the Interneting Project. They want to link these similar networks so that a host on one network could communicate with a host on another. There were many problems to overcome: diverse packet size, diverse interface, and diverse transmission rate, as well as differing reliability requirements. Internet today. Today we witness a rapid growth both in the infrastructure and new applications. The internet today is a set of peer networks that provide service to the whole world. What has made the internet so popular is the invention of new applications, World Wide Web, multimedia, and peer-to-peer applications. Standard and administration. In this discussion of the internet and its protocol, we often see a reference to a standard or an administration entity. In this section, we introduce these standard and administration entities for those leaders that are not familiar with them. The section can be skipped if the leader is familiar with them. Internet standard. An internet standard is a largely test specification that is useful to and adhered to by those who work with the internet. It is a formalized regulation that must be followed. There is a strict procedure by which a specification attains internet standard status. A specification begins an internet draft have a maturity level, proposed standard, draft standard, internet standard, historic, experimental, and informational. And also we will talk about requirement level, have a required, recommend, elective, limited use, not recommend. In this picture is a maturity level of an RFC request for comment. It have a internet draft to purpose standard to draft standard to internet standard and the end of historic. And you can see experimental at here, link to purpose standard, and in the right side have information, internet draft, link to information, and link to historic. Internet administration. The internet, with its root primarily in the research domain, has evolved and gained a broader user base with significant commercial activities. Various groups that coordinate internet issues have guided discourse and development. Appendix D give the address, email address, and telephone number for some of this group. We have ISOC Internet Society, IAB Internet Architecture Board, IETF Internet Engineering Task Force, IANA and ICANN Internet Assigned Number Authority, and Internet Corporation for Assigned Name and Number, and Network Information Center, INC. In this picture will be Internet Administration. The topic is ISOC, IAB. For the left side is IRTF. It starts from IRSG, and under level is RG. Next is right side. The right side is IETF. It starts from IESG, and under level is area, and under level is WG. Summary. A network is a set of devices connected by communication link. The internet today is made up of many wide and local area networks, joined by connecting devices and switching stations. Most end users who want internet connection use the service of Internet Service Provider (ISPs). There are backbone ISPs, regional ISPs, and local ISPs. A protocol is a set of rules that govern communication. In protocol layering, we need to follow two principles and two providers. Bidirectional communication. First, each layer needs to perform two opposite tasks. Second, two objects under each layer at both sides should be identical. TCP/IP is a hierarchical protocol suite made of 5 layers. It has application, transport, network, data link, and physical. The history of internet working started with ARPA in the mid-1960s. The birth of the internet can be associated with the work of Cerf and Kahn and the invention of a gateway to connect network. The internet administration has evolved with the internet. We discussed ISOC, IAB, IETF, IRTF, ICANN, and NIC. An internet standard is a authority test specification. An internet draft is a working document with no official status and a 6-month lifetime. A draft may be published as a request for comment (RFC), RFCs go touch maturity level, and are categorized according to their requirement level. So thank you for listening me.